G'day folks, I think we'll get started. Those that are late are going to be late, they're going to miss it. I'm David McMorran. I've been in this hobby for 20 years or something. I've been on this trail with signals for at least a decade. I had no idea where the technology was going. I had no idea what I wanted to do, no idea how to do it, and I could see the commercial products were expensive, so I thought there's got to be another way. So that's what got me into this trail, this rabbit hole. And Martin's going to help us out a bit.
All right. So just by way of introduction, my name's Martin. Bear in mind, I'm a navigator by trade, a qualified master mariner. I've been driving boats, or been driving a boat for the last 15 years. Our motto is keep it simple sums for simple sailors, and that's where we're going. I was introduced to I started modelling about 20 years ago in N-scale. I was introduced to T-track in 2009, then got introduced to signals in 2018, and then David introduced me to Wi-Fi instead of wires, and I've got to the stage now where I've got a prototype signal, I've got a lot of relays, I've got boards, detectors, things, and I've come to the conclusion that at some stage I've got to draw a line in the sand because the technology just keeps evolving that fast that if I don't, then I'm never going to get finished doing what I'm doing. So with that, I'll hand back over to David. He'll go through most of it on the case study today, so to speak, and you'll hear from me a bit later on.
There we go. Okay, I have never been working for the railways. I've never been working for any signals people, so I don't know anything. Just what I've read from the web. Thank you, Mark Bauer, for a great website. So some of what I'm saying may not be the right things to say, but it's what I know. I'm going to break it down into a few components structurally, just to help things go through. Talking about what you put on the layout, so what you see on top of the layout. Then there's wires that disappear into the abyss below, and there's a little bit about that. And somewhere there's some guy who's going to be controlling this somehow or other. There's no right or wrong answers to how you do this. If you're modelling Namibian railways, I suspect maybe you might be in the wrong place today, because in Namibia they don't have signals. They do everything by word of mouth. If they want permission to use a bit of track, then they get the permission. However, I do know a person who is modelling Namibian railways, and he is putting signals on it because he thinks they look good, and perhaps the layout's not complete without signals. So there you go. So whatever you want, it's your layout, you do what you want. I'm not going into signalling systems in detail. You've heard some of that today already. I'm not going into Arduinos particularly deeply. I'll mention them a few times. Certainly not going into programming. And what else am I not doing? Oh, other complicated stuff. Trying to keep it simple. Some of it might get a little bit complicated, a little bit maybe depends on your level of knowledge and what you're familiar with. So yeah, the shiny stuff is on the top. That's a good place to start. Now LEDs, so it's simple, right? It's simple, but there's actually quite a variety. You've got the stock standard LEDs that are, we've all seen plenty of those. 5mm and 3mm is the common sizes, but 3mm is still a bit big for N-scale, but if it has to be, it has to be. They've been around for donkey's ages. Then you've got the bipolar ones. That's not quite the right term for it, but I call it that because they work on current goes this way, one light comes on, current goes that way, the other light comes on. So you've got red and green LEDs combined, and if you switch them both, if you have alternating current, then you'll get yellow. So they're an option. They tend to be a little bit fiddlier to work with, so you don't see so many of those. Then hiding in this one, you can hardly see, is a bit more common variety of a three-legged LED. So it's the same deal with two LEDs cross polarised, whatever, cross directions, but they function independently with a common lead. Now, if you're going to use those, just be careful of the polarity. All right, there's the middle peg is the common one, and some systems require common positive and some require common ground. So you've got to just make sure you've got the right sort. Just be aware of that. Now, modern electronics is these surface mount things. Now, they can get really, really small. So that's for N scale. We want a little bit smaller. All these other ones are a little bit big. So there's options there, working their way into some commercial products. This little one down here, I found on the internet somewhere. Somebody pointed to me, I can't remember who it was. It's a really, really small PCB, and really, really small. So you can see that's a pen. So it's about the size of the tip of a pen. Right, so it has 3 of these surface mount LEDs on it. So they're, I don't know what the size are, but they're really small. So if you've got 3 LEDs, they've got 4 wires come out of it. So there's a common wire and there's 3 colours. So now you can control that to be whichever colour you want. So just a word of warning that they do come in red, green and yellow, and red, green and blue. So red, green and yellow has probably got a lot of prospects for signals, and red, green, blue. You can get yellow if you switch the red and the green on together. And then the blue, NeoPixels. As my son suggested, why don't you try NeoPixels? I tell him about signal, not that he knows, but he'd use these NeoPixels at uni. And what are they? I don't know. So Paul briefly touched on these in the previous session. They have a data signal to each one, so you can actually control it. They're made up of multiple LEDs, so you can display whatever colour you want. Now, Paul said, yeah, there's 256 levels of brightness of red and blue and green, so that's about 16 million combinations. The reality is that your eye can't tell the difference between most of them, and once they get over a certain brightness level, it's all just blurred anyway. It's just all white. So there's really a much smaller range that is more noticeable to us. I'll talk a bit more about that in a moment. Well, that one. There's another one that's hiding there. You can't see. It didn't come up very well on the screen. So it's shaped like the regular LEDs. They come in sizes of 8mm and 5mm, I think. So 5mm is probably all right for HO, but way too big for N scale. But they are this sort of technology. So there's a little chip. That little speck of dirt in the middle is a little chip that's processing information. So these ones that look like that, but they have that same sort of chip in them. And these ones, it's a merger of 2 technologies. So it's using these sort of LEDs, or these ones, but with the brains of this chip. So this chip is what's on this board, and you can put regular LEDs on it. Now, why would you do that? It's because of what they do. These NeoPixels, as I keep calling them, that term I think is getting out of touch a bit nowadays, I think. So the original ones were 5mm square. So I worked out, I did a little signal mast and put that on the back of it. It's the size of the disc. So it's too big, but I didn't know where I was going with it at that time, and I didn't have any options, so that's what it was. And the way they work is there's 3 wires. But each pixel has, each pixel has actually got 4 wires. So there's one that comes in and one that goes out, plus you've got your voltage. So you've got a positive voltage ground, and then there's a data. So the way it works is that the data comes in, the chip says, all right, the first chunk of that data is for me, the rest of it I'm going to spit out the other side to go to the next guy. So then he does the same thing. He takes the first bit for him, passes the rest on to the next guy, until either they run out of people and run out of lights on the string, or run out of data to send out. So then that means you've got one I/O pin that is controlling the whole string. Now you often see them, so here's a string of them, different densities of them, how they're packed together. You sometimes see them in Christmas lights because you can do all sorts of pretty colours with them. Sometimes they come in squares, which I didn't have. So yeah, there's prospects now of, and these things they're cheap. They're about 10 cents each or something like that, or less than that. So all of a sudden now I've only got one data pin. I need a tiny little Arduino or something to control it. One data pin, so there's not a whole mass of wires, and they're just daisy chained together. So the costs start tumbling down. Semaphores. I think what I said to some people is, yeah, semaphores have worked much the same. They're harder to do, so all I can say really is good luck with it. So you've got to start driving servo motors or something to push these things, because it's all mechanical, so it gets more tricky. If you want, yep, sure, and they look good, so maybe I'll get one on my layout sometime, but I won't be doing very many of them. A little bit of jargon I need to go through. Oh, that's dreaded word, semaphores again, Jesus. We heard a little bit today about 2 position, 3 position, first lower quadrant, upper quadrant. What does it all mean? This signal semaphore is the one that's outside of Nyora, on the western side of Nyora, right next to the bike track. I don't know why they want a signal on a bike track, but never mind. Maybe it was there first. So they have 2 positions. So Victorian Railways in the old days was 2 position with a single semaphore arm, and they were using the lower quadrant. So it's pointing out for stop and it's pointing downwards to say go. It only has 2 options. The 3 position is the upper quadrant, so stop is here and go is up there and caution is out there, 45 degrees. So there's 3 positions. Now, as we got into electronics and lights, those names are stuck. So we talk about 3 positions, but it really means the 3 colours. And then we get into aspects, 3 position aspects, but it's really 3 positions of 3 colours, but yeah, it gets a bit complicated. Won't go into it. I want to talk a little bit about what's a signal mast and what's a signal head. And I don't know what the right jargon is, but the way JMI uses it is we've got a signal mast over here. So you've got this 1 head up here and 2 heads. So it's not the number of lights, because this top one's got 3 and this one's got 1. So it's 2 heads on 1 mast. So the mast has got not just the heads, but it's also got the pole and the ladder and whatever else you might want to put on a signal mast. Now, I'm not going to tell you what you should put on a signal mast, as it's up to you, how much detail you want to put on it, how authentic you want it to look. Maybe you're happy with a brass pole with LEDs on the top, whatever. And aspect and appearance. An aspect, well, an appearance is the colour, right? So it'll be red or it'll be green, so it's the colour of a light. So that's a red. The aspect is the message that it's putting out there. Is what does it mean? So in this case, a green over a red means proceed at normal speed. It might mean something else in New South Wales. I do things differently because they're not as smart as us. South Australian people are much more intelligent because they do the same as us. So I'm talking about Victorian railways. I'm Victorian, as you might have guessed. So I'm talking about Victorian railways, so aspects I'm talking about Victorian railways. The aspect names are going to be different in New South Wales to Victoria. The appearances, they have different appearances as well, because they have flashing and white and other stuff, but I don't know all about New South Wales stuff. I'm sticking to Victorian stuff. Now, JMRI is a common tool that you might use in railways, for model railways, for controlling all sorts of things. You can control signals. And I always talk in terms of a mast and an appearance. Sorry, a mast and an aspect. That's what I focus on. So I'm not trying to turn a signal red. I'm trying to turn a signal to stop. So that's the difference. Right? So stop depends on what type of mast it is, whether it's got one head or two heads, whether it's got 3 lights, 4 lights or 6 lights. It still says stop if it's both red. So aspect is what I'm talking about at the level of JMRO at least. Somewhere down the line, you're going to have to convert that into signals to each of those individual lights so that they do what they're supposed to do. We'll come to that in a little while. So JMRI comes with a stock standard thing called the basic signalling system, or something like that. And they have four aspects of clear, approach, stop, and unlit. Unlit is dark, is the appearance. The light is off. Now it depends on what sort of signal you might want. If you just want a light to say that the points are clear this way, or you're clear to go through, that might be adequate for you. Depends on what you want. I'm keen to have more authentic looking Victorian railway signals. I should say at this point, it's an intention. I'm not there yet. It's been the path that I've been on for 10 years or so. I had no idea the technologies that I would need, but all those technologies over that time have fallen into place, so I do know now what I want to do. I just need some time to fix it all, do it all now. Okay. So aspects in Victorian Railways jargon. I'm concentrating on modern era stuff, so I deal with 3 position aspects. So that's 2 heads and this whole bunch of aspects. And I had to write the files for JMRI so that JMRI could understand Victorian Railways. And somebody said to me, what about 2 position signals? And I thought about that and do I want to do 2 position signals? All right, since you told me that and I know about it now, right, I should do that as well. So I have looked at 2 positions, and that was actually more complicated than 3 position, because the different sorts of signals with distant signals don't have a red because you don't stop at a distant signal. Repeating signals, so getting the logic for all of those was a bit more complicated. Okay, I'm just going to go through quickly a couple of commercial masts that are around. San Mateo line do some quite nice looking signal masts. They're mostly in HO, but they do some in N, and they are available in kit form as well as ready-made. N scale is probably more likely to be a kit. So as you can see, they've got a bit of all sorts, and they even have these dreaded semaphore things. I can't get away from them. So this is a photo I took from their display at the exhibition at Diamond Creek a few months ago. And they have these dials to change the aspect to whatever you want to change, so that will change the colours of the LEDs. And they have these little levers that you can actually pull and push, and it changes the position of the arms on the semaphores. So if they can do that, then you could put a servo motor underneath that, and they did have one on display as well with a servo motor driving it. So it can be done if you want. Good luck. This is a few that I've collected over the years. You might see them in shops or stands at exhibitions maybe, I don't know. Handmade accessories from Tasmania do a few things. In fact, I saw some outside today, but they were level crossing signals and just street lights and that sort of stuff, but no proper signals. CDA in Queensland did some. The websites still say they're available, but they're mostly HO, I think. So you might have to DIY. DIY, you can make it as elaborate as you want it or not. This is the one I mentioned before, a 3D print I did about 10 years ago, just to start exploring things about how I'm going to put all this together. I've gone to a different direction now, but I'll talk a bit more about that later maybe. Okay, underneath, where do these wires go? Switches, of course, you switch a light on and off, so you can have it controlled by just simple toggle switches. You want to change the colour, you can switch the lights on and off. DCC concepts have these things that look more like levers, but they are just switches. They're switching lights on and off. But if that's what you want, that's fine. And then there's these magic black magic boxes. I can't remember what I keep alternating. Is it black magic or is it a black box? But they are just electronic switches. They're just switching things on and off. Now, this is an NCE lighted module. So this is now getting into the level of how can you switch it from DCC, from a command station. I don't know of any throttles where you can actually set a signal. You can set it, you can close and throw a point, but I haven't seen any where you can actually specify a signal setting. But you can do it from a computer. So they use DCC track power as the input, so that's providing power for the lights and for the brains, and it's also getting the DCC signal, so it's getting the instruction to set this signal to whatever colour. So they have three colours, green, yellow and red, and a common positive, so it's a common anode. So if you're getting those three-legged LEDs and you want to use it with one of these, it's going to have to be the common positive type. And how's it done? It sends this aspect number. So the DCC signal is saying to set the aspect to this number. So this is straight out of the table from the NCE notes. So when you say switch it to 0, then that means the red light comes on. So if you're talking in aspects, it means stop. Okay. Obviously yellow and green for the next two, and the rest there, maybe you want party lights or something, who knows. You don't really need it for that, but let's move on. I'll come back to that one. How do you set those up in JMRI if you want to control it from JMRI? This is a screenshot where I'm doing you give it a username, whatever name you want for your light or your signal. I'm using Victorian Railways, I mentioned before. If you have a double head, like this one is a double head, and DCC signal mask decoder. So these are the aspects that it would use. Well, this would be just to actually drive the first one. You would use it'd be a single head rather than double head there. So Normal is 2, so normal speed is green. Clear normal speed. And you don't use those, I can't do those. That's how the message gets out from JMRI. So it's not just JMRI, it's part of the DCC protocols. Now a couple of other examples. If we're using these bicolour ones, the bicolour ones, you've got a red and a green with a common anode. Make sure you get the common anode, remember? So there's no yellow, so you need red and green to make it look yellow. So one of those options down the list was red and green. So that will give you the yellow. So you're actually only using the red and the green outputs of the NCE module, that you switch this one on or that one on, or switch both of them on. Now, if you're using a C light, this signal mask down here has got the third head, the C light, which is calling on. So what you can do is, if I was ignoring this top mask, if I was just doing this bottom one, I can say, if it was a single head, you can say 0 for red, 2 is for green, 9 is red and green, just as we did there, and 6 is red plus yellow. So the red light comes on the yellow. So you use that yellow light that you didn't use before, hook that up to your C light. So now your C light comes on. So you're going to have red and the C light. So that's a proper combination for Victorian railways. Now, if you're trying to do something like this, you've got 2 heads with 3 colours each, you're going to need 2 lighted modules, and you still haven't got your searchlight now because you're going to be using the yellow for here. So now all of a sudden the cost starts to go up a little bit. And just a reminder, with the San Mateo, I know they did manufacture some with common cathode, common ground wires, so they would be incompatible with the NCE lighter. You'd have to, yeah, you've got to, the person I knew that had one, he went back to them and they redid it for him, gave him a different one with a common cathode. So you can't change them easily. And just in case you're wondering, these 2 signals are just outside of Ringwood, on the upside of Ringwood. That's out in the eastern suburbs for those of you that are not Melbourneites. Yeah, other manufacturers have got hardware available too. I don't know a lot about them, mostly because I just see dollar signs. It frightens me off a bit. But they do some good stuff, and if you're doing a small number, it's probably worthwhile spending the extra to use something that's there, rather than to have to go into DIYs and work it all out and do it then. Well, it's not really hard, but a little bit more labour involved. But if you want to do a lot of signals, a layout can soon get fairly complicated, and the signals can add up a bit, and the dollars can add up a bit. The black boxes, we talked a little bit before about the Arduino Nano. It was the one I showed a bit earlier. There's an ESP Node MCU which has Wi-Fi. The little squiggly line up there is the Wi-Fi antenna, so you can always pick the ones that have got Wi-Fi on board. So it's much like this guy but with Wi-Fi on it. And then there's these little ESP01s, which are much smaller, about the size of your thumbnail. That's got the Wi-Fi on it, and that's what I use. I'll go into that a bit more in a moment. Okay, what does the controller do? There's a couple of options. You can do manual control, so you can actually have your switches and you switch each light or each lever, or whatever, however you're doing it. That's one option. Computer assist would be having all that hooked up to a computer, and then you might just click on a mouse to say, change this signal to whatever aspect or colours you want. Or you can go into computer control, where the decisions are being made up by either a microprocessor or a computer that's going to decide what signal needs to be displayed and send the appropriate commands out to it. I'm going to hand over to Martin again now, so he can tell you a bit more about what he's been doing, and I'll go in a bit more detail about what I'm trying to do afterwards.
All right, so this is, go. All right, so this is a section of what I have at home, T-track modules. So on these modules, down here I've got an automatic signal with the start of the block, another automatic signal there, and then I come around and then I've got a big game, and that's a 3-arm or 3-light home signal for the station module, which is here and goes further down than that. Coming out of the station module on the upline, I've got a automatic signal start, and that's protecting those points there as well, which I'll just talk a little bit about a bit further on. And then into another signal here, and finally just past here is another signal, and off it goes. So when I started, I wanted to, as I said, T-track. That's a T-track module. I wanted to keep it modular. So to keep it modular meant no wires between different parts of the layout. So I decided that I'd go with just 2-position signalling to, oops, sorry, wrong way. We'll go back this way. Okay, so I was going to go with 2-position automatic signals, and for signalling to work, you need some form of track detection. So whether that be infrared, current, and there's various ways of doing that. I was made aware of RR Circuit's BOD-H detector. There's quite a lot of notes on their website about their BOD-H, which includes schematics, diagrams of circuit board traces. So I started down the path of etching my own circuit boards, and hit and miss, sometimes get 2 out of 3, sometimes 1 out of 3. So I then went and studied up on how to learn a little software package for getting the files needed to get the PCBs manufactured, and I went off to a local mob over in Seaford in Melbourne, and I had the boards printed, and then bought the components and started populating boards myself. So basically, 2-position signalling. Trains comes into this block. Once as a train enters, signal shows the appearance of red, or goes to stop, the stop aspect, and next signal is green. As the train moves from this block into this block, this signal then goes red, or goes to stop. Your rolling stock is required to have resistive wheel sets for current detection, so that it can detect. To reduce the number of wheel sets that I needed to start with, got the locomotive as its own resistive wheel sets in its own right, and I'm putting resistive wheel sets on the guards vans. That way, loco's in this block, I've got a stop aspect, guards vans in this block, my signal remains at stop. Train moves forward wholly into the next block, first signal goes back to green, the next signal is still at green, so I can proceed. And again, this signal then goes to stop, and finally I clear this block, this signal goes back to proceed, and this signal's at stop and on you go. So to put that together, above the layout, you've got your signals, as Dave's touched on. Trying to be thrifty, I decided I was going to scratch build mine. After trying to put 6 wires down a 1/16th outside diameter brass tube, I've decided that maybe I'll make some and buy some. Under the layout, you've got the track on top, your DCC bus, your track detector for the 2 blocks in question here, and then output from the bod H triggers a relay. In the two position signals, we've just got the red and the green LED, and this isn't prototypically correct, because in the real world, the default for the signals is stop. So if the signal loses power, loses the track circuit or whatever, it'll go to stop, and then the signal can't go to proceed until such time as the technicians have been down and made the necessary repairs. In this system, being the simple sailor that I am, I haven't been able to figure out how to achieve that, and mine default to proceed, unfortunately. But anyway, you're standing there driving your train, so you should be able to see what's in front of you anyway if it is incorrect. But basically, the bod H detects, triggers the relay, and the contacts close on the relay, and the current flows down through the red LED and gives me the stop. And when the train clears the block, the bod H goes back to sleep, and the current then goes through the normal closed contact on the relay and gives me the green. So there's no connection between the modules around the layout, and so that was the modular system for me. I then went to, surely 3-position signalling can't be that hard, and this is basically 3-position signalling across the 3 blocks. Train in the first block, stop, proceed. Train in the first block, entering the second block, I've still got proceed on the 3rd block. And then here my train's cleared the first block, and my second block's at stop, and my first block's gone to warning, giving me a yellow appearance. And as you see, train moves on, stops up, and then here train clears block 2, block 1 goes to proceed, and block 2 goes to warning. Of going down the path of having 2 heads on my automatic signals, like Victoria. To keep it simple, again, I've decided that my signals are either going to be normal speed, so I've got changing colours on the top and I've got a fixed red on the bottom, or my signals are going to be set at medium speed and I've got red on the top and the choice of colours on the bottom. And that's achieved by here, a wire running between the relays. So I've gone from 1 relay to 2 relays, and again, it doesn't default to stop. So relay here is triggered. This block's vacant, so this detector's asleep. Input into the relay module, and my contact goes from to the normally open position and I get a red aspect. Otherwise, if this block's clear through the common, or through the normally closed I should say, into the common on the second relay, and if this block's vacant or isn't occupied, then this is asleep, and out of the through the normally closed contact to give me the green LED. If there's a train in this block, then this bod H triggers the relay number 1 to give me a stop aspect here, and with one wire back to the previous relay module, I've been able to trigger the second relay on the module, which gives me through the normally open position the warning. So this is under the first two modules in the downline in the first slide that I started talking about. So we've got in here, we've got our track detector. We've got a buck converter to give me 5 volts for my circuits, which is there. And here we've got the 2 relays to drive the lights. And then track runs down along here and round up that way. And I've wired up a signal here and have it sitting on the top of the layout. Currently it's 2 LEDs running up through a piece of heat shrink tubing to give it a little bit of stiffness. And then on this module here, because there's 2 signals in this area, one on the upline, one on the downline, I've got 2 detectors. Again, buck converter to give me the 5 volts that I need from the 12, and the relay module, 4 relays so I can operate my 2 signals, and out of the relays, and I've got as far as taking it all to terminal blocks, and when I've got the signals built, then I'll pop them through. And the orange wire is what joins those modules at present. Going on to, all right. I then went to a meeting and David gave a talk on using Wi-Fi as a means of communication between, or around the layout between various input-output devices, and went, they can make relay switch. Maybe I can use them. This involves a messaging protocol called MQTT, which talks to a broker off the layout, so it's a little bit further advanced from being purely modular and nice and simple. The messages are a bit like DCC digital packets. So the input-output device, it waits for a message, listens to the messages and go, oh, that message is for me, I need to act on it, and it'll then do what it needs to do. And it's also got input pins, so we take when the train's in the block here, the bod H detects, and it triggers an input pin, gives it says I need to do something. That input pin then sends a message off to the broker in one part of the program, and then the broker sends a message off around the world, so to speak, being my little world, and then devices that are listening for those messages from that device there, then act on it. As with most things with computers, a lot of it's been, the programming side of it's been done. The last thing you want to do is go and reinvent the wheel. So there are people around who are willing to share their information and what they've done when it comes to getting down a bit further into the nitty-gritty of it all. So David was talking about his ESP01 and his Node MCUs. So that's a little board for anyone who wants to come and have a look at it with a ESP01 mounted on it. And that's got 2 I/O pins, so that's suitable for small devices. And then the Node MCU, which he touched on before, which has got 5 pins and a little bit more suitable for what we're doing under some modules. So this module here is actually this module here, 2 tracks on that side and some wiring underneath and some bits and pieces I'll pass around shortly if anyone wants to have a look at it. But basically, we've got the black box here, we've got the track detector here, we've got a relay module here. Just for the moment, ignore that relay module there. I'll talk about that in a tick. So again, the detector, and this is a module which was the departure signal from the station module that was on the left-hand side of the picture before. So detector detects and then inputs to the black box. The black box then outputs a message to the world, and it drives this relay here, and that gives me my stop aspect. It listens for messages from around the layout, so it'll hear a message from the next block if it's occupied, and it'll go, it's occupied, so I've got to trigger that relay there. And if this block is clear, then when it triggers, I'll get the warning aspect. And if both blocks are clear, well then it comes through to and gives me the green appearance. We might move on from there. And then we get to, and then I've, again, trying to keep it simple, keep it self-contained, or reasonably simple, reasonably self-contained. That represents a set of points which were on the, if you remember my U-shaped section of track where I had a siding up the top. So what I've done is tried to protect that rather than have another signal sitting here close to the points protecting them. I've done my protection back here at the start of the block. So first up, the points are closed, then, or in the normal position for the Victorians. Then trains go, and I skip the first relay module through the normally closed here into the second relay module. A baud H outputs from the input-output device to the second relay, and that'll give me, if there's occupancy, that'll give me the stop aspect, and on you go. So points are thrown, then we're on the first module, and we get the stop aspect. So in the picture, that's the first relay that's controlled by what's happening with the points on the module. I think that's probably about it. So yeah, that's where I'm at. I'm about to go to how to drive a 3-arm signal, or three heads, to give me the point protection for my home signal for my station. So I'll set up as permanently warning medium speed, so it'll be fixed red on the top, 3 aspects on the middle, and then my C light which will give me points of, if the track's occupied, points are thrown, it'll give me a stop aspect with or give me a low speed caution aspect telling me that the points are thrown, you proceed 15 kilometres an hour and be wary that there might be something on the track in front of you. That's a little bit further down the track, so to speak. There you go.
Okay. Okay, so now I'm going to talk a little bit more technical about what's behind using Victorian Railways from JMRI. So I'm using JMRI to control things rather than Martin's just using the occupancy detection to trigger the signal change. I'm just relying now on that occupancy being reported to JMRI through whatever mechanism it has, and JMRI will decide that the signals need to be changed. So that's the direction that I'm heading. I've mentioned some of these before. Basic signalling, yeah, that's fine if that's what you want, and there's no problems with that. If you just want to see points have been changed, you want a red light, that's fine. I'm just interested in Victorian Railways because I'm that way inclined. The DCC, I've discussed before, DCC controlled aspects, sending out the message. I'm using MQTT. It's a technology that was developed for lightweight messaging protocols for sending messages from remote pipelines out in the desert to measure gas flow and that sort of stuff. But it was in the desert, so they didn't have much power available to them. So it's very lightweight protocols, and it's just an industry standard. So it's not a railways thing, it's not a model thing, it's real life messaging. But it's lightweight, so you can put it on a Raspberry Pi and it's not going to put any load on it at all. So wherever you've got JMRI running, just install the hub component of MQTT onto the same computer. And I've already discussed aspect number and aspect names, and so names is what I'm going by. Now, Victorian Railways. When you go into JMRI, you can see this massive long list of different railways for looking at protocols for what aspects they use. There's lots of American ones, there's European ones, Czech ones, all sorts of things, but what about Australian? There's nothing that was Australian, so I decided, all right, I'm going to write my own. So I've got Victorian Railways comes up on my list. Now that doesn't mean you have to do that, because I've already done the hard work for you. So you can just get those files from me. I'll give you a link there in a moment. You can download those files, the instructions on putting them into the user files area in JMRI, and then all of a sudden Victorian Railways will be an option on your list. That's all you have to do. If you want New South Wales Railways, then you're going to have to find somebody to write it for you. Probably I won't, because I don't know anything about New South Wales. Nor am I anxious to. And if you're using South Australian, well, you just pretend you're part of Victoria for a little while and that'll all work fine for you. So how do we set all this up? First of all, putting MQTT into JMRI, it's all there. When I started down this journey, this wasn't an option. I found out about MQT as an option, but it wasn't in JMRI, so I couldn't use it. Eventually it came about, so now I'm happy. So you just you just click on the plus button here to add an extra connection, and you choose MQTT from the list. And you go into the advanced settings. It requires the address of where the MQTT software is. You normally put it on the same machine as JMRI, so localhost means the same computer. So that's what you have to put in there. You can just leave the rest as defaults. these have track/turnout, which is part of the messages that get sent. Track is a little bit verbose, it's unnecessary to me, so I cut that out. So I just write turnout, but you don't have to. So that's MQTT setup. It's not particularly complicated. You don't have to know more about how it works. You don't know how DCC works, it just works. So MQT is not much different. Now I've got these same two signals from before, these two that are outside of Ringwood. So I'm just stepping through the process of how you would set those up in JMRI. Okay, so you go into create a signal mast, and you start up here. You give it a name. I've given it Ringwood 223 because that's Ringwood 223. Took me a long time to come up with that name. And this one I called Ringwood 302 for some reason. So you choose, next on the list is the railway system. It comes up by default as the top of the list. You go down, select the one you want. The second time around, it assumes the same one as you used before, because that's most likely. So you don't have to keep searching all the way down the list. Victorian Railways will be the default. So you've got that. Then you choose which sort of mast you've got. Now you can see there's a whole bunch of 2-position ones. There's more 2-position ones than 3-position ones. Because you've got all these different sorts of home things. The arrival signals, they have arms all over the place in 2-position signals. You can get 5 different semaphore signals on one mast, and how do you define all those? That's where it all got complicated. But you can have that if you want it. So choose what you want. The mast driver, instead of having DCC, I choose MQTT. So now when you get to see what it's come up with, now instead of having the options of where you put in the aspect ID, there's no such thing now. We just use these aspect names. So when MQT, or when JMI is now issuing the instruction, it's telling it the name of the aspect rather than an ID number. So in the case of 223, there's 2 heads. Because it's the searchlight for the bottom searchlight is fixed at red, that means it can only display normal speed signals. It would need extra lights like this one to be able to show medium speed. So this one can only show normal speed signals. So that means that these 3 options there would become redundant. So you can just click on disable for those, so that then they won't come up. In the case of this signal, we've got a C light. So I've got double head plus C light, and you can see it's got the extra aspect there for when the C light comes on. So this is showing the signal table, the list of signals that you've got. I'll only put those 2 in. It's got these complicated looking system names, but the DCC ones are a bit complicated as well. With signals, they look much the same as that. It's got the username, which makes more sense. And you can see now I can actually select whichever aspect I want to show, and you'll see that those 3 that I mentioned before you would disable don't come up on the list because they don't apply to that signal mast. If I clicked on this one, then for 302 for this signal, then you'd get a longer list of options that you can choose. So I can control my signals just by selecting the aspect at that point. Yeah, what goes underneath? Since I started this journey 10 years ago, when the neopixels were 5 millimetres squared, the latest versions are 1.5 millimetres squared. So that is just about the right size, the perfect size for N scale. And yeah, 13 cents each. The 1515 is just a code for 1.5 by 1.5 millimetres. It's got fairly small solder points on it. There's 4 wires that have to get soldered to each one. Like I said before, there's a voltage in, the ground, a data in and a data out. So there's 4 connections to each one. Come back to that in a minute. And this guy, yeah, well, when I bought this one, it was $2 a few years ago, about the size of a thumbnail. Yeah, inflation, it's $3.50 when I looked it up recently. You might be able to find them cheaper than that, particularly if you buy a number of them. And so this has it has 2 data pins on it, so therefore I can have 2 strings of LEDs that come off it, and I can have as many of these LEDs on it as I want, within reason. So the number is pixels you want, you multiply by 13 cents, and then add $3 for one of those. Now setting it up on the actual ESP. So this is software that goes on this. Now you might have seen these in Paul's presentations earlier today. So they're quite often used with Arduinos, because Arduinos don't have Wi-Fi. So these are often used to give Wi-Fi access to an Arduino. So it converts Wi-Fi into a serial connection for the Arduino to make sense of it. So these are on some of those DCCX modules. I'm writing sketches on this module. All right, I need to fess up a little bit here. MQ Trains. Some of you might be aware that I'm part of the team that's developed some of this software. There's a couple of guys in Texas that make up the team. We've written software that goes on these for throwing points, for I/O connections, same sort of technologies as you saw earlier with Paul. But we're using Wi-Fi as a method of getting the communication back to the command station or whatever is controlling. In our case, it would be JMRI, or in my case. That means I have to run a DC power supply, but that's the only extra power connections I need. The signals are all via Wi-Fi. You want different coloured lights. You can define whatever red, green, blue values that you want. And I mentioned before that they tend to get very bright very quickly. So setting numbers as low as 14 out of 256, that's plenty bright enough for these sort of lights. If you're using the little circuit board with LEDs I mentioned before, which I have one here, so these are ordinary LEDs. They will need a lot more power, so I would have to, if I had these in my string, I would have to increase these numbers probably up to 200 or more to get those bright enough. And we define aspects. So this is, JMRI is going to send a message to say, set my signal to stop or whatever else. So I have defined in here the list of aspects. And then we get to where the magic happens is what I do is I have a particular type of mask. I select from here which type of mask I've got. In this case, I didn't have all the 2-position ones, but they'll get there one day. This is not available at the moment. This is software that's under development. Has been for a little while. It's been delayed a bit because team members have got day jobs, model train conventions, health issues. So those sorts of things have put a bit of a hold up on things. So this is in development. This is an early version. It may look different when it's finished, but shows you the direction we're heading. So for Victorian Railways, I've got the list of aspects that are applicable to this type of mast, and it knows because it's two heads, three position. So it's telling it there's two lights. So for each light, I've got to say what colours I'm going to set. So then that will apply to all the masts on your layout that are of this type. So you're probably only going to have a couple of different types of masts. So you've only got to do this setup for that couple of times. And then all the individual masts are just going to pick this up, this mapping up. Yes, this too is picked up by the definition of this mast type. So then we go into individual masts. So these will be position, it says there, that's actually the sequence on the string of the pixels. So the first one, there's different types of masts that could be theoretically on this list. So I define, I've got an ID number for my mast, and the sequence that they are. Each one knows by its definition of how many lights it's got. So therefore, the string is being built up. So I'm going to be building up 2 pixels for this mast, 1 for this one, 2 for this one, 1 for this one. And if it had more lights, like the 6 colour light signal, then there would be, and if I got a C light, there could be 7 for one mast. So that's how it's building up the string that's going to send the message out to all those. Sounds more complicated to describe than it has to do it. All right, there's a couple of links there for interest sake. San Mateo from Mildura. I've mentioned these before. If you want my VMR, Victorian Railways signal files, you can get them off GitHub from that link. Just download it from there and it's got the instructions on it. There's a green box that says download here, so that's the one to click. If you want to know more about JMRI signals, you can have a look there. That's generic JMRI signalling. And MQ Trains has its own website and stuff there. As I said before, it's your layout, you do what you want. If you want something simple, a layout looks good if you've got some signals on it. Railways do have signals, so even if you just want to make it simple, go for it. Hopefully I've tried to take some of the mystique away from it to show you what's under the covers, how to make it work. It doesn't have to cost a fortune. Maybe now, maybe that can help you understand a bit more about what's involved, and maybe you can get into it yourself. Every layout could do with some signals. Even Namibian railways can have signals. Any questions? Not too many because Martin's in a hurry.
Second last slide, the references. Thank you.
Who's got signals on their layout? Not me. I'd like to.
I've got one.
Is it one? I gather people might be interested in having a go at it, so I'll just encourage you to have a go. It's not that hard. It sounds complicated, but leave the complicated stuff to somebody else. If the work has already been done, just use it. Get them to help you set it up, maybe.
I'm interested in the T-track because that's my interest.
Yeah.
But the way you were describing, I imagine you need them in a particular order. how does, even with the wire communication, then if you move them around, you just plug the wire in, but with the Wi-Fi communication, is it broadcasting, my module is occupied?
Yeah.
In which case you then need, the next module needs to go, oh, I need to.
Yeah, you need to keep, so with the initial setup, it's self-contained. When you get to the Wi-Fi, then you need to put your modules in, keep them in the same sequence. If you're taken from home to an exhibition and you want to run the signals, and you need to set your modules with the detectors up underneath them and the I/O devices, you need to keep them in the same sequence that you have them in your home layout.
So,
Pardon?
How difficult is it to change?
It's a little bit of coding, so you'd have to into the Arduino IDE and change some numbers and upload the files to the I/O devices each time. So you could take your modules to a show, and you could just run them as 2-position signals. So you might have the three LEDs, but you'll only use the stop and the proceed.
just one point I'll add to that is, if you're going to use it for T-Track, a lot of layouts are modular. T-Track is just very modular, very small modules. So Martin and I are both using T-Track modules as our home layouts. That means it's a layout that is in a set formation because there's reasons for the sequence of the modules to be in that order. So it is a layout as such. They're not just randomly put together. So it's worthwhile going to that effort if you want to signal it as an entity. To set it up as a random thing for whatever exhibition you might have, that's an extra challenge, something different. But as Martin said, yeah, you'll probably go with 2-position and make them independent.
Because at the end of the day, at the exhibition, most of the people there don't know that that the signals have the 3 lights, and I got into it in a lot of ways was to provide some animation to provide some interest to the punter that's coming along to have a look.
Can't beat flashing light.
Yeah, wind turbines. A little bit of motion, but yeah, the lights get them in. And yeah, I spent a lot of hours looking at Little Rock Junction layout, particularly at Sandown, watching the lights change colour before I started crawling around the back and having a look to see how we actually did it. But yeah, it was the coloured lights that got me in.
One question about pottage.
Yep.
Is it converted out?
Well, I'm a simple sailor, so I can't answer that for you. All I can tell you is that through the opto isolator, yeah, one wire goes to ground and the other wire goes to the I/O device. So when it's occupied, when the pin goes low, then it broadcasts a message to say I'm occupied.
Yeah, because I was looking at it as to convert that more like the real thing. In other words, when the block's occupied, the signal will go to red.
Yeah.
And if it remains occupied, it will always be red. Rather than the opposite way, it's the moment where it's turning green.
Yeah, I'm not sure how you go with if you put a voltage on the input pin. I suppose at the end of the day you probably can. It's not something that I've looked at because it was probably a little bit too difficult for my level of knowledge.
Thanks.
You define the logic the way you want it. These things put out a row when it's occupied. That's fairly common with a lot of sensors. So in your processor that's reading that, you can send a message to say that the track is occupied, active, if you want active as occupied. So you reverse it then.
Yeah,
Yeah, I'm more than happy to go and stand at the bar and have a beer and talk about it and work out whether we can do it or not.
That's right, good job.
Thank you guys very much.
Okay. Thank you.